So in the warm-up, it says solve the differential equation. The first thing I'm going to do is actually rewrite this. Instead of y prime, I want to write it as dy dx because I think it makes the first step a little more obvious. What is the first step to solving this? By doing what?
Changing, no,
it's 2x times 1.
the sides. I don't know how to say. Reordering them.
Yeah, you're getting there. So separation of variables, right? We need all of the y's on one side, all of the x's on the other. Remember, on the AP exam, if you get a problem like this as your free response and you do not use separation of variables first, you are going to get 0 points. 0. Like, they don't give you partial credit afterwards. Because if you don't separate your variables, then all of your work after is basically null and void.
So it's dy by y.
So y dy is equal to? And then what? Right, then we can actually integrate it, like you said originally. So the integral of y is y squared over 2. And then the integral of 2x is just going to be x squared because the 2 is constant. And those 2's will cancel. Plus c, right?
And then you have to multiply that by 2
Yeah, I can multiply everything by 2 and say y squared minus 2x squared is equal to c or something like that. You could even call this a different c because then you've multiplied your c by 2.
Do you have to simplify it all the way, like y is 2x plus square root?
Nah, I mean,
Wait,
depending on what it's asking you to do, I would probably just leave it like this at this point.
Wait, why do you want, why not the y? Okay, that's
Why not solve for y?
yeah.
Well, that's what he was just asking. Can you? Sure, you could say y is equal to 2x squared plus c's square root.
That's, you see, like, these are the things that make me confused, and then I don't understand because I think I'm wrong, and I don't know.
No, it's not wrong. That's right. These are equivalent.
You just like come up with things.
These are equal. Either one is fine.
And when it asks solve the differential equation, does that mean just like, what does that exactly mean?
So you're given a dy dx and you have to solve for y equals.
Oh, okay.
You're solving for that original equation, okay? And the equation is different depending on where you are in the graph.
Okay.
Think slope fields. That's what that plus c represents because, and that's why, Nika, that's why here I solve for c because I know my next step is going to have to be solving for c given a point x comma y. Okay, so I just made it easier for the next time around. But that's about it.
So your final answer has to be y is equal to?
Ultimately, it should be something like that. Yeah. So growth and decay models, in many applications, the rate of change of a variable y is proportional to the value of y. If y is a function of time t, the proportion can be written as follows. So dy dt is equal to ky. If I need to derive the general solution, how do I solve for y equals something? Separate our variables. So I have dy dt is equal to ky. I could bring my y's to one side, so that's 1 over y dy is equal to k dt. I recommend when you're solving something like this, that other constant k, leave it on the other side. Always get your y's on one side and leave everything else on the other side. It makes your final solution, your general solution or your particular solution, a lot cleaner arithmetically. Okay, so all of the manipulations of the equations that you guys are not so good at will be a lot easier. Okay, so I already have this here, so now I can integrate each side. What is the integral of 1 over y?
ln of y.
Ln of y. is equal to k is constant. What's the integral of k dt?
Like KT.
Good, kt, right? Plus c. What can I do from here if I want to solve for y?
Put everything to the e.
Yeah, e to the whatever. So that gives me y is equal to e to the kt plus c, which I can actually rewrite this. I'm going to write this as c1.
Wait, why?
We did e to the on each side. Okay.
And that equals 1, right? Or no?
E to the ln of y
Yeah, that equals 1.
equals y. And then e to the kt plus c we left is e to the kt plus c. But I can actually think about x to the a plus b, how that can be rewritten as x to the a times x to the b, right? So I'm going to do that here. I'm going to say e to the c1 times e to the kt. And this e to the c1 is a constant, right? So I can just think of it as a new c and think of the whole thing as c e to the kt. What does that remind you of? Or does it remind? Right, pert.
You can't bring KT down?
No, but you wouldn't want to. I mean, these definitely are related, right? They're the exact same equation, just this growth and model decay happen to use different variables. Okay, so that's where it stems from.
Wait, why? Okay, can you explain the e to the c1?
E to the c1 is a constant, right? So I'm representing it as c, as my new constant c. That's why I called it c versus c1. You know that it's slightly different, but it's still a constant nonetheless.
Do you have to say that?
No, but I wanted you to see the relationship between what we did and how they get to that growth and decay model of PERT. Okay? And of course, if you're in this equation, y equals c e to the kt, you're talking about c being the initial value, k is your proportionality constant, and then if your k is positive, and then it's going to be a growth, and if your k is negative, then it's going to be a decay.
That's
Correct.
only when the derivative is related to the value, right?
I'm talking about for our
Or y
proportionality
constant.
constant, yeah. Okay, and then at the bottom here is actually the work that we did at the top.
Oh, and why are you using the new app?
Why am I using what?
There's a new app.
Oh, I'm using Explain Everything because
Waiting for Santi.
Oh.
Santi wanted to record.
Hi,
Yeah.
Santi.
Hi, Santi.
So e to the c is equal
We
to
miss
c.
you.
I think he's gonna watch it.
E to the C is a constant, so I'm calling it C. Yeah, just so that you could see that relationship there. Okay? In example 2 here, it says using an exponential growth model, the rate of change of y is proportional to y. When t is equal to 0, y is equal to 2. When t is equal to 2, y is equal to 4. What is the value of y when t is equal to 3? So because y prime is equal to ky, we know that y and t are going to be related to that equation, y equals c e to the kt. All right, so maybe we should write that out. Because y prime is equal to ky, we know y and t are related to the equation y equals c e to the kt. And we can use our initial condition to solve for that equation to solve for what the value of y is at that point. So so our y is 2 when t is 0, right? So 2 equals c e to the 0. Anything to the 0 is 1, so this implies that our c is equal to 2 when y is 2 and t is 0, right? And then we can use our other condition when t equals 2, y equals 4. So 4 is equal to 2 e to the 2k, because our time is 2. We're using the c that we were able to find from the first initial condition, and then with that secondary value, we're able to figure out what our constant of proportionality is, our k. If I solve for k, how can I rewrite this?
If you solve ln,
Wait, how do you know that the C is
Uh-oh.
equal to 2?
What just happened? How do I know what?
That C equals to 2.
We plugged in our initial condition of y equals 2 and t equals 0. And that allows anything to the 0 is 1, so we just have c equals 2 left. Then we're able to plug in our c equals 2, our y equals 4, and our t equals 2 into the equation the second time. And that allows us to, if we divide by 2 on each side, actually I'm going to bring it the other way. I want k to be by itself. That's just going to equal 1/2 ln of 2, good. Which if you plug into your calculators, you get 0.3466. Some of you guys still aren't writing out at least 3 decimal spaces.
because the 2k, you have to get the k by itself. Because ln of 2 is 2k, and then you do 1 divided by 2.
Can you take that 2 out of the k, like 2k, can you put that 2 to the front or no?
You mean if you ln each side?
If you,
Can you divide each side by 2 and get 2 equals e to the 2k?
Because I got 2 is equal to e squared times e to the k.
I don't understand how you did the ln.
I wouldn't necessarily separate them at that point, because if you ln each side at that point, then you're able to get,
Okay.
right?
Can you explain how that happened? Like, why is it k equal to 1/2 ln?
Sure, if I divide each side by 2, I get 2 is equal to e to the 2k, right? If I ln each side, I get the ln of 2 is equal to 2k. And then I have to divide by 2 to get k by itself. Okay? Once I plug that into the calculator, I get 0.3466. And of course, that's when t is equal to 2 and y is equal to 4. And now I can write that general equation. Y is approximately ce to the kt. 2e to the k, 0.3466t. That is my general solution.
Wait, is it the rule like ln of 2 equals to 1/2 ln of 2? Like,
What?
how does ln of 2 equal 1/2 ln of 2? Is it the rule or
How does
ln of 2 equal to 1/2 ln of 2?
it doesn't?
But
I ln'd each side, so I have ln of 2 is equal to ln of e to the 2k. Okay, another way to think of it here, Nika, another way to think of this is if I rewrote this, right? I have ln of 2 is equal to, this can come to the front, right? So I have 2k ln of e. What's the ln of e? 1. So I have ln of 2 is equal to 2k. I'm solving for k. So I divide each side by 2, which gives me ln of 2 over 2, or 1/2 ln of 2. Right? You see that? Okay. So here, what is it actually asking for? Well, it says, what is the value of y when t is equal to 3? Well, we have our equation now. We just have to plug in 3. Exactly. 0.3466 times 3. And if I do that, I get 5.657.
Wait, shouldn't it be 3e?
No, because my c is 2,
Oh, okay.
right? Okay. Let's try another example with that, with radioactive decay. So it says, suppose that 10 grams of the plutonium isotope, plutonium Pu-239, was released in the Chernobyl nuclear accident. How long will it take for the 10 grams to decay to 1 gram? And it gives all these radioactive decay measurements in terms of half-life. Half-life, operative word. Okay. So let's write out that y equals ce to the kt. Our initial condition is what?
Your 10 grams will release.
So y is going to equal 10 when t is 0, right? So if I plug that in, I have 10 is equal to ce to the 0, which gets us to the point that c is equal to 10.
Wait, is it saying that 10 grams to... But doesn't plutonium decay into, what is it, beryllium and...
Decay into what?
Doesn't matter
Oh,
what
there's
it
things...
decays into.
Yeah, but then you're going to have more grams when it decays into something.
Yeah, but it's just asking about the... Right. So it's now asking half-life. Well, if we started out with 10 grams, how many grams are we looking for half-life?
You want to decay to 1 gram.
From 10 grams?
No.
For half-life?
Half
5, right?
5.
So y equals 5 when t is equal to what?
1 or 1 half life.
1/2 the
So that's 24,000.
So it's 12,000.
24,100, right? It takes 24,100 years for half of the plutonium to decay. So if that's the case, now we can plug into that equation again, but this time we know we want to end with 5 grams, and we start with 10, right? E to the, our T is 24,100. K. K is what we're trying to figure out. Okay? So that K, if I divide out, I have 1/2 is equal to E to the 24,100 K. If I ln each side, I get K is equal to 1 over 24,100 ln of 1/2, which if I plug that into my calculator, go ahead and do that. Tell me what you get.
876 to the minus 5.
Negative 2876 to the minus 5, so that's negative 0.1234. What was the number? 2876?
Well,
Okay.
You do 288, right?
Yeah, we'll leave it. We've already got 0.000, you know, may as well. So that means my general equation is going to be y equals 10e to the k negative 0.00002.
I'm so sorry, but can you expand? Like,
Can I what?
like,
Explain? Yeah, it's the same process as where you got stuck before. So hold on, let's go back. So that's right here. If we ln each side, I have ln of 1/2 is equal to ln of e to the 24,100k. This comes down. So ln of 1/2 is equal to 24,100k times the ln of e, which we said is 1. So if I'm just solving for k, I could divide by 24,100. And I get k is equal to 1 over 24,100 ln of 1/2.
why do you divide 24,000?
Because I'm trying to get k by itself. This is 1, right? Does that make sense? Yeah, no problem. Okay, so we have y is equal to 10e to the negative blah, 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 t. And in general, we have our grams started out with 10, and we're looking at a decay to 1 gram. So if I were to set up this equation so that I could solve for the time, because it says how long will it take for the 10 grams to decay to 1 gram, now we've written our equation in such a way that we only have that single variable. Before, we would have had too many variables. That's why we had to do the half-life and use the amount of time it took for the half-life, and knowing that we started with 10 grams, that half of that would be 5 grams. We had to do all of that so that we could actually get the proportionality rate of k. And now we have this equation with a single variable, and we're able to actually plug in. So we have that our g, our initial value is 10. We now want to say, well, how long will it take for us to reach 1 gram? And that's where we could solve for this t value. So go ahead and plug into your calculator and tell me what t is going to equal.
We got 80,062.0686.
How'd you do that?
It's really close, but I got 80,059. I'm wondering why.
I got 80,062.
I probably.
Did you store your value
Oh no. Right. For which one?
for any of these?
No, I didn't store anything.
You
And
didn't
you have to
to.
simplify for a t first before plugging it into the function.
Yeah, I plugged it in
Well,
as
you
negative
just do-
ln 10 over.
No, I understand, but negative 0.000287 is a rounded amount,
Oh yeah.
What was the answer?
right? 80,059. And in fact, it was 80,058 point something.
What did
Derek also got 62.
Yeah, we're all getting 62. So it
We
has to be
definitely
that.
got 58 point something last
Wait.
year,
Yeah,
last
ln of
last
1.
Yeah,
period.
it must be.
It must be in the rounding.
Yeah.
So if you store your values, that's why it's important to store and not just round your values. But you should get, and I'm not going to write 80,058 point something because it's saying how many years, and at that amount, I might as well round to the next largest year, right? Because if I do 80,058, it hasn't reached that amount, it hasn't decayed to 1 gram yet.
And question, in order to simplify
How'd you
for the
get
t, you have to do the same thing.
ln
with
of
t,
1
right?
over 10 times.
Yeah, where you ln each
Yeah.
side.
If you do it without rounding, it comes out to 58.
Okay, so make sure you're storing your values. You know, if you write it on your paper, you can round it, but when you're actually calculating it, you want to make sure that you store your values so you're as accurate as possible.
But it's not rounded down. It's not rounded up to 58. It's also close to 59.
I know, but what I'm saying is it wants to know when it reaches 1 gram, and you can't say 80,058 years because it hasn't reached 1 gram yet. You still need those extra months to get to it. So if you're going to answer the question in a full year, you have to go up,
So
right?
where are we round wrong on that .0000287?
If you store that value instead of, then you'll get your
Yeah.
answer. Exactly. Okay?
Okie doke.
All right. Let's do one more. Separation of variables. Find the general solution.
No, we
So what do I have to do first? Separate. What does that give me?
So dy, or would you move the x squared plus 4 to the other side?
Sure.
And then you'd have first dy times
So
1 over y.
you're saying do this,
Yeah.
then bring the y over here. This is no longer here. Bring this over here. Right?
Yeah.
So that gives me 1 over y dy and x over x squared plus 4 dx. Right? All right, so if I integrate each side,
ln of y. And then u is, you have to use a u for this one.
Y.
yeah, you can use a u here. So u is equal to x squared plus 4. My du is 2x dx. So that's going to be 1/2 ln of u, right?
Just be 1/2, 1/2 ln x squared plus 4.
Okay. Plus
Plus
c. I'm going to call it c1. In fact, I can even bring my 1/2 up just to kind of simplify it a little bit more and have it just be the ln of the square root. That way, if I e each side, there's got to be a better way to do that. Write it exponentially. That's going to give me y is equal to plus or minus e to the c1 times the square root of x squared plus 4, right? And this again is a c, it's a constant. So I could say y is equal to c square root of x squared plus 4.
What would happen if you didn't move that 1/2 there? Make it square root? Would you have to eventually?
It would work out that way, yeah, because you'd have that 1/2 kind of just floating there. So you'd end up with 2 times, yeah.
Wait, how did that happen that e to the c1?
Because
Go ahead.
you just grade everything, because to get rid of the ln you have to do e to the, like you e both sides, you e both sides and
No,
then,
no, stop. Can you explain please?
okay.
Sure. So I have ln of y is equal to the ln of the square root of x squared plus 4 plus c1. Just like before when we did the ln of each side to simplify things, here we already have ln. So if we do e to the value, because this already has a natural base of e, here and here,
But then
Right, so the same idea holds then. So if e to the ln of e is y, of y is y, here e to the ln of e is going to equal this whole thing, right?
Yes.
So that's what we're left with. Because it's plus c1, it's like saying e to the everywhere.
So wouldn't it be plus e to the c plus c? Why is it c times x squared?
Because you have e to the a plus b, which is equal to e to the a times e to the b,
Oh,
right?
it's not e to the a plus e to the b.
It's not e to the a plus e to the b.
That's what I thought it was.
Right, no, it's not. This whole thing is together.
But if you wrote it like that, would you get it?
Ah! What?
Would that be wrong though on an exam?
Would what be
If
wrong?
you don't simplify it like that with the multiplication and you keep it as addition? Like if you just
Well, the thing is that it's asking you for the general solution, so they want y equals
what if
something.
you had y equals plus or minus and then e to the x
C1,
plus
yeah,
plus
that's fine.
C1?
Mm-hmm. Yeah, that would be fine. Of course, you know, the next thing they're going to do is actually give you values and have you plug in. So if you don't have to deal with an E, it's just a little bit nicer. Right?
Yes.
So, okay, find a particular solution given the initial condition y equals 0, or y of 0 is equal to 1. Find the particular solution of the equation.
Separation of variables.
Separation of variables. Ay, 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 ay.
I just subtract that left, that right, the right side to the other side.
This to here? Or you went the other way?
The other one, but it's, either way works.
Okay. So that gives me e to the negative x squared y squared minus 1 dy is equal to negative xy dx. I can divide my e to the negative x squared, and I can divide my y to get rid of y on this side and the x's on this side. That works. That's why I moved the other one over, just so I have my y's on the left side and my everything else on the right. So if I rewrite that, actually before I integrate, it's really just y minus 1 over y, right? And on the left side, I have negative x e to the x squared, because if I bring this up, it becomes positive, right? Dx, and that allows me to go ahead and integrate on each side. So I get y squared over 2 minus the ln of y. Okay, so my u, ugh, there's a very funny delay with this. So you said u is equal to x squared, so my du is going to be 2x dx, so that's going to be negative 1/2. Negative 1/2 e to the x squared, right? Plus c. Now we can apply our initial condition. So what do I get? right? You could leave it there. You can multiply everything by 2 just so you don't have to deal with that 1/2. Maybe I'll do that. Ooh, yeah, I definitely want to do that because if I do that, I get, watch this. If I multiply everything by 2, not only do I get rid of the fraction in the first one, but 2 ln of absolute value of y, that 2 can come up as the exponent, and then I can drop my absolute value because it's always going to be positive, right? So I could just write it as ln of y squared plus e to the x squared equals 2.
Wow.
I like that more.
Solve for y.
No, because we have y squared, but we also have the ln of y.
I know.
That would be really, really, really bad. Record on this. So, -1, sorry, Santi, forgot to hit record.
I'm not sorry, but I'm sorry.
Derek's not sorry.
Derek knew all along.
Derek knew all along, didn't say
You just
anything.
told me to record it.
Okay, so if I solve for y, what do I get?
So for y, you get e to the. So wait,
E
So
to the,
it's y equals,
e to the
y is
x
e
is
to
minus 1.
C times e to
E.
the negative x, 1 over x.
yeah, c times e to the negative 1
No, but you can
Yeah,
put the c,
mhm.
you can say c, whatever you want.
over.
Good.
Whatever, you know.
That's right.
Just math.
As long as I call those other c's something, right? And then I need to apply my initial condition,
I don't remember it. You have to look it up.
which was, what was it? Y of 1 is equal to 3.
I don't understand how like you put the C down. How does it?
This is a number, so I'm just calling it number c.
Okay.
Why you put C1 though?
Because this c, this is not equal to this. So I want to distinguish between the two. Okay? And I know if I threw a totally different letter in there, it'd really throw you. So I'm going with C1 and C.
Oh, because
Shooting.
ln of that? Is that why?
Yeah. All right, so if I plug in y equals 3 and x equals 1, I get 3 equals c e to the negative 1, or c is equal to 3e. So what's my final going to be? My c is 3e, e to the negative 1 over x.
Can you multiply out 3?
Not so many people.
Solve for that?
Can I multiply out?
Well, can you solve for that? 3 times Z?
I just need to work out.
Oh, well, I could do this. I have 3e to the 1 times e to the negative 1 over x, bless you, which is the same thing as saying this, right? Which, if you don't like that, you could write it as 3e to the x minus 1 over x to get a common denominator. And then, of course, x has to be greater than 0 because we're talking about a solution curve. If you look at your original, you can't have x being equal to 0, and you're not going to have a negative value because it's x squared. So that's what I'm going with. Preguntas?
No.